Welcome back, everybody. This is Sienna Raccoon, and we will be continuing in our Let's Make a Game series. In this video, we will be covering variables, data types, and if-else statements. But before we can start on that, let's look back at our last piece of code that we did in the last video. So the last thing I told you before we close off in that video was to move your code from your start method and place it in your update method. So that's exactly what we're going to do. So we're going to hit Control C to copy this line of code. You can press space or enter to delete it. And then we're going to go right here into our update method, hit Control V. And then we're going to hit Control S to save it. And now we're going to head back over into Unity. You can hit play. And we're going to see what changes did that make to our game. So let's head over to our console log. And as you can see, we have the same message where it says hello. But if you look over here to the right, as you can see, there's this number that's constantly going up. So what is this? So basically, this is how many times this one line of code is being called. As you can see, it's already been called over 1,000 times in just a few seconds. So this is how powerful the update method is. We use the update method for constantly checking something, constantly making changes to something. And it actually goes right back to the script itself, and it shows you that. So right here, the line of code, I'm not sure if any of you guys actually got what this meant, but it says right here, start is called before the first frame update, which would be this. And as you can see here, it says here, update is called once per frame. So what this is telling us is that start is called before anything is updated. So generally speaking, how these two methods work is you want to use your start method for initializing stuff. If you want to basically set up everything for the game, if you want to declare variables, I'm going to show you what variables are in just a second. If you want to just set all of your stuff that you need for your game, and then after you set everything, you come in your update method and you make changes as needed. So that's basically how these two methods work. You use your update for, as it says, updating frames and your line of code. But generally speaking, we don't use update for all of our updating strategies. The most important thing we would use update for is if we're basically checking for player movement and just for anything moving or physics code in general. Anything physics related is what we would use our update for. But I'll show you guys all of that in later videos. How to properly optimize your code and how to make sure your game is performant given the tools we have. All right, so that out of the way, let's get into the lesson. So let's start by talking about variables and data types. So what are data types? Well, the best way to give it to you is by giving you this drawing right here of this cookie jar. So as you can see in the cookie jar, we have the jar itself, we have the cookies inside it, and we have the label. So the best way to look at data type is think of the data type as the label. You can think of the cookie jar as the variable, and you could think of the cookies as the value. So the basic idea of how these things work is you call what kind of data type you want, you give it a label, and then you add a value to it. And that's essentially how you make up data types. Now, obviously, there are more sophisticated data types and variables, but genuinely speaking, this is how we structure them. You give it an identity, or you give it a data type, which is what we generally call it. Then you give it a name, which would be the variable, and then you give it a value. So that would be in this case, the cookie would be the value, and the jar would be the variable, because it's a container. We're using it as a container to contain whatever we need inside, the value inside the jar. And then yeah, the data type would be the label, because we're declaring what kind of variable that we want to make. In this case, it would be a jar for cookies. So that was just a basic example for anybody to catch on to. Here's a more practical example of how a data type and variable is structured. So as you can see in this example, we have this line of code that says int cars is equal to 4. Now, before we could go over this, let's talk about the different kinds of data types. You have 4 different kinds of data types. You have ints, which is short for integers. You have floats, which are basically just numbers with decimals. Strings that contains text, and booleans, which are basically just values that return either true or false. And here are examples of these 4 main data types. As you can see, the int, it's just a whole number. Now with the float, as you can see, it has a decimal place, but it also has an F at the end of it. And this just is so it makes it very easy for the code editor to identify that this is a float. Because if you don't put that there, then it's going to be a little bit of confusion between this and an integer. So it's just really easy to just put that F there to make things as clear as possible. And then as you can see for the string variable, it has an open and close quotation mark. So anything we put inside those quotation marks will be declared as a string and a string only. Don't try to create variables inside a string parameter. And last but not least, we have the bool. So the way how the bool works is it's literally only going to return 2 values. Either it's going to return true or it's going to return false. And that's basically it. All right, now that we have the 4 basic data types down pat, let's say we wanted to do a practical example of how this works now. Let's say we wanted to make 4 declarations. We'll use the 4 main data types and we'll run them in our start method and we'll see what Unity has to say about them. So let's start with int cars is equal to 4. Remember to use a semicolon. We can say our float, let's just put this as money or budget, whatever you're feeling, is equal to 4.50. And remember to close it off with a C. C# is already making a complaint. Visual Studio is making a complaint right now saying that something's not right about this line of code. So let's put an F at the end. As you can see, the squiggly line went away. Now let's close it off with a semicolon. So it's very important to put your F's at the end of your float variables. Now we have a string now. Let's put in the string name, because we're using string for the text. So whatever we put in these quotation marks is going to be printed exactly as we type it in Unity. So we could just say, this is our data. And we can close that off with a semicolon. And then last but not least, the Boolean. A Boolean is represented with just bool. So you can come here and we could just say trigger, I guess. I like using trigger for Booleans because Booleans usually trigger an event. That's what they're used for. So we just put here true. And there you have it. Those are the 4 basic data types. Again, these are what you'll be using when you need to create your game. Now, we're going to put all of these in our start method, and then we're going to run it. So we're just going to say debug.log. And because now that we declared these variables, we actually do not need to put in the raw code anymore. The way how we did that in the last video, we just put in raw code. That's not typically how we do it. We usually should put in our variable, and it's going to come up just the same. So let's go. We could put cars right in here, our same cars variable. As you can see, it's highlighted blue and it's highlighted green up here, which means that it's the exact same variable. And then we can close that off with a semicolon. And now we can do the same thing for money, but before we just go ahead and type everything, let's hit Control D to copy this exact same line of code and put it on our next line. Control D is very useful if you just want to put the exact same thing but on a different line and just slightly edit it. So we could actually just do this 4 times. And now we could just go right here and change the variable. So we could double click to highlight it and just change it to money. Now as you can see, money is now highlighted. That's what we want. Let's go to the next line, double click it, change it to name. All right, and last thing, trigger. All right, that's that. And now we could hit Control S to save it. Not sure why we're still getting this same griggly line. So you could just change it from name to names. And then if you're gonna do that, please be sure to come down here where it says name, and let's change that to names as well. So now we're talking about the exact same variable. All right, so hit Control S. And we can head over back to Unity now. Okay, so now that our code is compiled, you could always tell your code is finished compiling because the buffering symbol that was here, it should be gone. We could clear this now, press the clear button, and now we could hit play. And now we can switch over to our console log. And as you can see, we are getting our 4 data types. So, and we're getting them in the exact same order that we placed them. So we got the 4 for the integer, the 4.5 for our float, this is our data type for our string, and the true for our Boolean. And we still have that one line of code that we had from the beginning of the video. As you can see, it's still being run multiple times per frame. So yeah, we could go ahead and take that out though. We can delete that always. So all right, so our code is working. This is good. This is what we need. So we could stop Visual Studio. We could stop Unity. We could head over to our line of code again. And we could, first let's delete this. We don't need this anymore. That was just for the example. And now what we're going to do now is we're going to talk a little about if statements. So the question is, what is an if statement? To give you an idea what an if statement is, it's basically an enhanced Boolean, whereas what it does is it's asking for a condition. Once you put in those conditions, it's going to check to see if those conditions are met. And if the conditions are met, which means if it's true, a line of code will be run. Whereas if it's false, then the if statement will be completely ignored. So let's just do that very quickly so you can see a practical example of it. So we're going to type in our start method. We're going to say if. Let's just use raw variables for now. 4 is less than 5, which is true. This will always be true. 4 will always be less than 5. We could use our curly braces now. What we're going to do is after we create these curly braces, press enter to put them on a new line. So it looks much easier to read. And now we're going to print out something to the console log. So we're going to say debug.log. We could say 4 is less than 5. Let's hit Control S to save it. And then we can press play. Oh, we were supposed to clear. Make sure you clear that line of code before you start playing. Okay, and if you come down here, you can see 4.5. These are the variables we got because we never deleted that line of code. And then it says right here, this is our data, true. And now the next variable that we just added, 4 is less than 5. And the reason we got this is because once again, we're checking to see here if 4 is less than 5. And this will always be true. And since this will always be true, this code will always execute. Let's just say, for instance, we wanted to test something. Given that our int number and our float number are both, well, they're both numbers, but obviously one is a whole number and one is a decimal. What do you think would happen if we was to try and run that in this if statement? Cars is less than, as you can see, we didn't get any errors. We're still talking about the exact same cars from up here, which is good. Now let's change this 5 and let's put money. Head over to our console log. And as you can see, we're still getting the exact same value. So the last thing we will be testing is Boolean, which in my opinion is my favorite if statements, because we can use these to create switches and basically anything we want to turn on and off. So let's get rid of that line of code and let's get rid of, let's just get rid of the quotation marks. So in here, we only need to check if trigger is equal to true or false. That's all we're checking in this line of code. We don't have to put anything else here. We're just checking, is trigger equals to true or is it equal to false? So with this, we can create switches now. We can create something that can turn on. We could create something that can turn off. I'll show you practical examples of these in a later lesson. But yeah, this is very powerful right here. We could literally check if something is on, and if something is on, we could execute something in this line of code. So it's really powerful to be able to. All of these are very powerful, but in my opinion, I think my favorite would be to check for booleans because of the simple fact that you could turn something on or off with just the flip of the switch. Just create another variable, bool, and we'll just call this testing. Equal to, let's return false instead. So we can come over here and let's get the value for testing. Oh, sorry, testing. And we can hit Control S to save that. As you can see here, we're getting a false now. All right, and the last thing I'm going to show you will be the else statement. So if something is false in an if statement, we could use the else statement to run something else. We do not have to put any parameters for our else statement. We only have to put the curly braces. Okay, so what we could do now is let's return this as false. So what we're doing now is we're checking to see if something is false. And if something is not true in here, aka if something is false, we're going to ignore this line of code and run what is ever in this line of code. So let's hit debug.log, open quotation marks, this line, oh, sorry, can't type today, of this line of code is false. And check the console log. So as you can see, we changed the value from true to false. Well, we're checking for something false. And then it says right here, this line of code is false. Let's head back over to Visual Studio very quickly. So yeah, that's what we're doing here. The value trigger is equal to true, but we're checking to see if something is false here. So since we're checking for something false and this value is true, this line of code will be completely ignored and it will jump straight to this line of code. So the last thing I'm going to show you now is the else if statement. And all the else if statement does is it's returning the exact same else statement but with parameters. So what we're doing is we're checking to see if something else is true instead of returning straight to false. I'll just show you a very quick example of that. So we already have our else. All we have to do now is put if, and you're going to see it's going to sync up with these, which is letting us know that it's still the same if statement. We're just checking if something else is going on. So we could just put here, we could return the exact same values we have up here if cars is less than money. Oh, sorry. Okay. And as you can see, it's set up exactly like how an if statement is set up. But we're checking to see is if something is not true, let's check to see if something else is true. So let's actually put that in our notes right here. What we could do in C# and in just about any coding language, we can create comments. And comments are just basically ways of putting lines of text without the compiler ever seeing or reading it. So let's just put in 2 forward slashes. As you can see, this line here is green. So anything we put in here is going to be completely ignored by Visual Studio. It's not going to read this line of code. We will not get an error. We will not get an error if we was to run this code now. But what we're going to do here is we're just going to put in our notes. This is true only if the conditions are met. And then we can put down here, right underneath it, we could put again 2 slashes. And then this returns true only if our if statement return false. So that's just a little side note, something to keep in mind. And again, if we was to hit Control S and save this, it would not be read by Unity. Unity would completely ignore this. And as you can see, that's exactly how we have these line of code right here in our start method and our our update method. I deleted the one in the start method, but that's essentially what these things are. These are comments. It allows you to make notes in your code without ever being read by the code editor. It's very useful for wanting to just set a quick reminder of something. If you want somebody else to read your line of code and you want to make the job much easier for them to understand everything, you would put comments in, so it makes things much easier to read. So as promised, you guys made it to the end of the video. So what I'll do is I'll close this off by giving you a little something to work with. We're going to spawn our first object inside Unity, and we're going to show it in our game view. So the way how we're going to do that is just trust me on this one. We're going to put up here public game object. Make sure that your game object has a capital G and a capital O. It should highlight green here, showing you that it's we're getting an instance from a class. Don't worry about that just yet. We'll cover this in a later video. And now we're just gonna hit cube. Okay, so this is our variable we just created. We just created a game object named cube. Now we want this to spawn in our game. So what we're gonna do is we're gonna go over to our start method and we're gonna type instantiate. Okay, now instantiate is a method created by Unity, and the way how we're going to spawn this game object is we're gonna open parentheses, type in cube, and close that with semicolon. And once you've done that, your code should look something similar to this. And then hit Control S, save it. Now we can head back over to Unity. Okay, so what we're gonna do here now, we could create a game object cubed, but the problem is it's going to show up in our hierarchy, which would make this a little less effective in terms of learning. So what we're just gonna do for now, again, just trust me on all of this. We're gonna hit create, hover over the 3D objects, click cube. Now what we're gonna do is we're gonna drag this cube inside our assets folder right here, and that's gonna create a prefab. So basically we just created a saved cube that's going to exist for our game. It's showing up right over here. Now we could delete, as you can see, it's blue, which means over in our hierarchy, it's highlighted blue next to the object, which means that we created a prefab for it, and it's showing up here in our assets. So we could just delete this instance of a cube. We could right click, go over to delete, and now that is deleted. So now let's go over to let's select our game object. As you can see now in our game object, we have this exact same game object that we created in our Visual Studio. It's named cube, just like in Visual Studio. Exactly the same, capital C cube. But now it's asking for something. It's asking for a game object. So what we're going to do now is we're going to use this exact same prefab cube that we just created. And we're going to drag and drop that right in our sample script. And now, as you can see, we actually have a cube instance right here. So what we can do now is we can press play in Unity, and this is going to spawn a cube in our virtual world, in our game. And as you can see, lo and behold, it doesn't do much, but our cube is right there. We could go over to our scale thing right here, and as you can see, if you scale it, you could see a much better view of it. This is our cube we literally just spawned. And if we go over to our hierarchy, it's going to say cube clone, because this is an instance of this exact same asset that we used. Okay, and if we go over to our scene tab, we're going to see it in our scene tab as well. We'll be messing around with the scene tab a little bit more. I'll show you how to navigate in the scene tab in the next video. As you can see, we have our cube right here. We could use these arrows to mess around with the values for, oh sorry, that's our empty game object. This is the instance. We can click on the cube right here in our scene view. Remember, this is our scene view. We can click on it, move it around, drag it. And as every time we're doing that, you can actually see the values for its position being changed. But again, we'll just go over all of this in our next video. So don't worry about this. I'll explain everything in the next video. But that's going to wrap it up for us here. Thank you so much for watching this video, everyone. Please be sure to like and subscribe, and just be on the lookout for other videos. This has been Sienna Raccoon, and I will see you in the next one.